This video will cover the second page of notes for the topic of dividing polynomials. We will continue practicing synthetic division as we go along. First, let's talk about the remainder theorem. The remainder theorem states that if p of x is divided by x minus k, the remainder is equal to the value of p of k. For example, we had the example 3x cubed minus 2x plus 5 is divided by x minus 3, and we found that there was a remainder of 80. Here's what we did using synthetic division. What the remainder theorem says is that the remainder, 80 in our case, is the same value one would get if you let x is equal to 3 and you found p of 3. Remember, p of x is our dividend, or 3x cubed minus 2x plus 5. Let's do that here. Let's let x equal to 3 and find p of 3, which would be 3 times 3 cubed minus 2 times 3 plus 5. And using order of operations, we find that p of 3 is equal to 3 times 27 minus 6 plus 5, or 81 minus 6 plus 5, which is 80. In example number 1, we had p of x is equal to 5x cubed minus 6x squared minus 28x plus 8, and we divided it by x plus 2. We found by synthetic division that there was no remainder, or a remainder of 0. By the remainder theorem, we can conclude that p of negative 2 is equal to 0. Note that we are using x is equal to negative 2 because we are solving the divisor of x plus 2 equal to 0, just like we did for synthetic division. The factor theorem states if and only if. Note that the IFF stands for if and only if. We'll talk more about its significance in a moment. But the factor theorem states that if p of k is equal to 0, then the divisor x minus k is a factor of the polynomial p of x. The if and only if means that this statement can work in both directions. One way would be if we know that p of k is equal to 0, then x minus k is a factor. The other way would be if we know that x minus k is a factor, then we know that p of k is equal to 0. So for example 1, we found that when we divided p of x, which was 5x cubed minus 6x squared minus 28x plus 8 by x plus 2, there was a remainder of 0. By the remainder theorem, we can say that p of negative 2 is equal to 0. By the factor theorem, we know that p of negative 2 is equal to 0. Then we can conclude that x plus 2 is a factor of p of x. So to sum it up, if you do the synthetic division of p of x, where the divisor is x minus k, and there is a remainder, then we know that the value of p of k. If the remainder is 0, then that value p of k is equal to 0, and x minus k is a factor of the polynomial p of x. Recall that factors divide into a number exactly. For example, 3 is a factor of 12, since 12 divided by 3 is 4 and has no remainder. 5 is not a factor of 12, because 12 divided by 5 is 2 with a remainder of 2. This concludes this video.